And here we go. So this is our first and really our only lesson in trigonometry. We are going to do another lesson on Thursday, but that's just taking this information and doing word problems with it, right? Trigonometry, as I mentioned in the announcement on our course, it's a really, really fun unit. I love working through it with you guys in class. You normally find it like a relief and easy after a stressful quadratics unit. And I just find the word problems get to be so fun, which you probably hear me say that and think, great, they're going to be awful. But they just get to be ridiculous situations, and it's all about triangles. You've been drawing triangles for most, if not all of your school life. I'm betting you drew some in kindergarten, and we're going to keep building on that today. So what is trigonometry? It's the study of the relationship between sides and angles in, you got it, triangles. The word trigonometry comes from the Greek trigonon, which means triangle, and metrikos, meaning measure. So trigonometry, measuring triangles. In its earliest forms, this branch of mathematics deals with the measurement of triangles and is used chiefly in surveying, navigation, astronomy, and some scientific applications. In more advanced forms, trigonometry has little connection with triangle measurement, but finds its application in fields such as electronics, wave motion, and business cycles. We will be focusing on its basic form with surveying, navigation, and triangles. In grade, I believe part in grade 11, more in grade 12, you look at it in terms of functions. I'm not going to be doing that with you. And it is actually a very applicable thing. So you will use trigonometry if you are doing any sort of building, whether it's profession or just you're doing a home project. I have a friend who's an arborist, so tree care, and he uses trigonometry every single day for estimating tree heights and lengths of branches. So if you had a chance to do the GeoGebra warm-up yesterday or look at some of the questions, you would have started by identifying the side lengths of the triangle. You'd look at the hypotenuse, you'd look at the opposite, and you'd look at the adjacent. Now, hypotenuse is always the same side on the triangle. And one more key point, all of our triangles must be right triangles. So they must have a 90-degree angle. There is trigonometry to do with non-right triangles that we normally would be doing, but guess what? In the span of 2 lessons, we won't be getting to it. So in a right triangle, tell me where we find the hypotenuse every single time. The hypotenuse will always be across from the right angle. And I know some people might say, well, it's always the longest side. We're going to have some triangles where some side lengths look fairly close. They aren't the same, but it's tough to tell. But very reliably is it's always across from the 90-degree angle. The other 2 sides, opposite and adjacent, they're all relevant to what angle we're talking about. So here the question says the sides opposite and adjacent to angle A. This is our point of reference here. So the side length that's opposite would be the one across or opposite from that angle that we're talking about. Right? Across. The adjacent one, adjacent means beside. And so our adjacent side length is beside angle A. Angle A has 2 adjacent side lengths, but one of them is the hypotenuse. So we name that the hypotenuse. Now, given these angles, what we use these primary trigonometric ratios for, what we use these buttons on our calculator, the sine, the cosine, and the tangent, is there are known ratios and measurements that in a right angle triangle, we can compare 2 of the side lengths, and we're able to know the angle. It's lovely that we have calculators that do this now. Back in maybe your parents' time, they might be a little bit young, but in my parents' time, they had this massive, like they had a ruler. It's called a slide ruler, and you can look up some videos on it. And that was the way they had to find it, not just punching a few buttons. So these ratios, the sine of angle A, I would write as sine A. It is not sin. Math is not a sin, guys. It's a blessing. Sine A is equal to the opposite side length divided by the hypotenuse. The cosine of angle A is equal to the adjacent side divided by the hypotenuse. And the tangent of angle A is equal to the opposite side length divided by the adjacent side length. So these are our primary trigonometric ratios. What you may have heard it called before, what I will definitely be referring to it as, is SOHCAHTOA. How are you supposed to remember the ratios? SOHCAHTOA. Okay, so sine of the angle is equal to opposite over hypotenuse. So cosine is equal to adjacent over hypotenuse, ka, and tangent is equal to opposite over adjacent, toa. If you write SOHCAHTOA at the top of every question, you'll never mix up your primary trig ratios, because I would hate for you to know how to do it, but get it wrong because you were using cosine with opposite and hypotenuse. SOHCAHTOA. Now, how do we do this on our calculator? We're going to look at that with an actual question. So we're going to go to number 1 on the next side. Determine each of the ratios to 4 decimal places. Okay, this is to find a ratio given, we're given the angle. So on my calculator works on method A, in that I need to enter the function first and then the number. Your calculator, and actually quite a few calculators, you have to write the number first and then the function. So you're going to have to test this out. On mine, for example, to determine the ratio of an angle of 38 degrees, I press sine, and then I put 30. Okay, so that gives me, I want 4 decimal places here. So my ratio is 0.6157. Make sure they know how to use their calculator to get that number. This is normally the point in the lesson that I'm running around the classroom helping people. So if you can't get it to work, please speak up in the chat. You guys also normally help me out a lot by helping your desk partners, and we don't have any of these options right now. If you got it to work, find our other 2 ratios, please. Cosine 82 and tangent 23. Please tell me what you get to 4 decimal. Oh, sorry. I know what else we need to double check. And you guys watching now may all be fine, but those of you watching the recording later, make sure this symbol DEG is showing at the top, because there's a few different functions. Now, on my calculator, you're going to look for a button that says either DEG or DRG. And when I press it, that gives me degrees, radians, and gradians. Yours may just cycle through it. If you see the letters rad, it is not rad, it's bad, or grad, which you are also not a grad yet, okay? So rad and grad are bad. You will get the wrong values because your calculator is using a different set of references. So make sure it says DEG. Once you got that, tell me what our ratios are for cosine 82. Kendra's got it, thank you, 0.1392, and tangent 23. 0.4245 is correct. So what do these numbers actually mean? That means if I had a triangle, I'm just going to talk about A right now. So I have a right triangle, like so. Here's angle A, and it's 38 degrees. This is my opposite, and this is my hypotenuse. Well, this means that the opposite side length divided by the hypotenuse, I don't know what they are, but I do know that when I divide those two side lengths, I get 0.6157. And this is true for all triangles where that angle A is 38 degrees, no matter the size, because triangles can zoom in and be smaller, zoom out and be larger. Picture what it looks like on a Word document when you're sizing out a shape and it keeps the same proportions. So that's getting the ratio from the angle. Now we need to know how to get the angle from the ratio. Normally, to isolate A, we would just divide by sine, right? I want you right now to do 0.7845 divided by sine. Well, the calculator does not care for that. And here's why. Sine is a function, okay? It's not an actual value. So that would be the same, similar to me saying, oh, divide 7845 by multiplication symbol. You can't do it. It makes zero sense. So instead, we do what is called the inverse function, which I write with a little -1. So that's inverse sine. And I do it to both sides. So inverse sine and sine cancel each other out, and I'll get my angle A. To do this on the calculator, I need to use my second function button. So I say second sine, and then I enter that ratio, 0.7845. I'm asking to the nearest degree. Okay, so we're going to round to the nearest whole degree. So Grace, you had the right answer, just needed to round a little bit more. And that gives us 52 degrees. Make sure you include the degree symbol. B and C are the same, but instead of using inverse sine, we're going to use inverse cosine. Instead of using inverse sine, we're going to use inverse tan. Yeah, thanks, Grace. Our answers are 81 degrees and 34 degrees. Now, is there anyone whose calculator is not cooperating right now? Okay. So, Victoria, are you able to get an answer? Just maybe the wrong one. Okay, Marissa, you too. We are going to figure this out. It's going to have to be me asking you guys some questions. So when you say, let's test this, I want you to put in tan 12 and tell me what number you get. Okay, Marissa, do you get that number? All right. Victoria, we're going to come back to yours in a second. Marissa, does your calculator say DEG somewhere at the top? Does it say RAD? Does it say G? Yeah, okay, it says RAD. I need you to look for a button that either says DRG or DEG. And you're going to press it and you should see it change at the top until you see DEG show up. Okay, did you get this value then when you press tan 12 this time? Perfect. All right, Victoria, on to yours. Are you able to get an answer if you were to say second tan 0.25? You got 12. Does yours say DEG at the top? And you got 12 for this, eh? Let's try another one. Let's say second sine 40. Okay, mine doesn't even like that. That's interesting. Okay, that's if you said sine. Let's do an inverse function. Let's do second sine. Oh, I know. Second sine 0.3. So inverse sine of 0.3. Okay, you need to make sure you're doing the inverse sine, Victoria. So press the second function. Did you get this value? No. What did you get? So you press second and then the sine button again. So if you look closely, I'm going to zoom in on mine. Where's my sine button? Right above sine in orange, it's the inverse. So if you're doing the inverse of sine, you'll press second and then the sine button. It's like a shift key. Awesome. Okay, you're back on track with us. Thank you everyone for your patience. All right, so for this triangle, find the trigonometric ratios for A and B. Express all ratios. It says fraction. I want you to express it as a decimal. But it's going to be 2 steps. So remember, SOHCAHTOA. So the sine of angle A, sine is equal to opposite over hypotenuse. So what is the side length opposite to A? Three. Yep. And hypotenuse? 5. And if I were to put that as a decimal, it'd be 0.6. Try that for cosine and tangent of A, please. And hopefully you got these 3 answers, 0.6, 0.8, and 0.75. We can now use any of these 3 ratios to find angle A. And how would you do it? Well, you'd use the inverse function because now we have sine A equals 0.6. It's the same as these questions above. So use the inverse, so second sine times 0.6, and that will give you angle A. And I get 37 degrees. Check the others and see if it's true for the cosine and the tangent. It's the same. It's the same again. All right, so that's why it doesn't matter because these are all ratios. Basically reduce to the lowest form of the comparison between those side lengths. Repeat this for angle B, please. So recognize that the side length that was opposite to angle A is different than the side length that is opposite to angle B. And I know you might be thinking, I can just use a triangle rule to find B. Yeah, you can. But guess what? We are practicing our trig ratios right now. So do that, please. When we use ratios, we go to 4 decimal places. So you'll see that, you know what, yeah, we do have fairly similar numbers here, but it's different functions. And so it'll give us different values. Find angle B using the inverse trig function. What do we get as our measurement for angle B? .53 is correct. And again, it doesn't matter which ratio you use. You may find that you have a favorite function. I do. I don't know why. I like using one more than the others. But they all work the same. Let's use it in a slightly different way, because what we can now do, if we know an angle and one side length, we can find that missing side length, because sine 36 gives us the ratio, right? The proportion or comparison between side lengths. If we know one of those side lengths and the ratio, well, we can do some math to find the missing side length. What do I want to do? I want to isolate x. So over here, I'm going to multiply both sides by 12. Be careful how you enter it in your calculator. All right, if your calculator is one where you do have to do the angle, then the function, you're going to enter this backwards, 36 sine times 12. If your calculator is like mine, where you enter the function first, you'll go forwards, 12 times sine 36. And we want this x, this missing side length, to one decimal place. Victoria, is your calculator cooperating now? Have you been in line with the rest of the numbers? Okay, good. Is anyone else's calculator rebelling? Did you guys get 7.1 as our x value? Probably, because you're all very smart people. Repeat that for this other side then. Isolate x. To do so, I'm going to multiply both sides by 8. So I'm left with 8 times tan 40 equals x. Thank you, Victoria. I got 6.7 as well. It's really not so bad, right? The more you do this, and I could have gone into a lot more background or theory or understanding, but we know we're pressed on time, and I need you guys to be able to find these missing values and use your calculator for grade 11 math. That's about it. You're going to learn some crazy trig laws next year, and I love them so much, and I miss teaching it right now. But for now, SOHCAHTOA is all we're doing for trigonometry. Let's flip the page over and find this missing information. So, sorry, nope, I lied. We're down here. We have to solve for an unknown side length. What you're going to do, I'm going to zoom in a lot on A here because it's pretty small. Solve for the unknown side. That means I'm solving for x. So I have to ask myself, when I look at SOHCAHTOA, I need to pick the ratio that I have 2 of the 3 pieces of information. And I'm actually going to label. Here's my angle. So I've got opposite, adjacent, and hypotenuse. With this here, if I did sine, that would be opposite and hypotenuse. I have 2 unknown values. I can't solve for one of them. That rules out. So cosine, okay? Here, cosine, I know the angle, I know the adjacent, I don't know the hypotenuse, but I've got 2 out of 3, so that's an option. Tangent, I know the angle, I don't know the opposite, but I know the adjacent. So that means that that ratio would work as well to find the unknown. Which of these two should I actually use to find x? So, ka or toa? If we used ka, that would give us the hypotenuse. Are we being asked to find the hypotenuse right now? The unknown side, yeah, the unknown side is marked with the x, so we want to use toa. So I'm going to start by saying tan theta. I know in Greek it's pronounced theta. I'm falling into improper pronunciation habits from all of my learning, and you'll most often hear it pronounced theta equals opposite over adjacent. Remember from grade 9, that symbol is theta. It's an unknown angle. So it's basically just a placeholder for an angle. Now I'll sub in what I know. I know my angle, it's 20. I don't know opposite, but I do know adjacent. Solve for that missing side length, please. Yeah, we're going to go to one decimal place. So even though it's 4.00, remember I'd multiply both sides by 11, and I get 4.0 equals x. Ta-da! Move on to B. Write out SOHCAHTOA. Ask yourself, what do you need to find? Which ratio will help you? Here's opposite, here's hypotenuse, here's adjacent. I see that I want to solve for opposite. So any of these that don't include opposite, like cosine, boom, worthless. So between the other ones, which one would I use? SO or TOA? So is correct because I have my hypotenuse, right? TOA would be using adjacent. I'd have 2 unknowns. So I'd start with sine theta equals opposite over hypotenuse. Fill in what you know and solve for unknown. And I get 9.3. Yeah, Grace, great job. Now C, I'm switching up a little bit. I switched the position of those values. I want the hypotenuse to be the unknown, and this side length here to be 17.5. So relative to this angle, I have opposite, hypotenuse, and adjacent. Your first task, tell me which ratio will help us solve this. Cosine or ka is correct. Why not sine? Because that would involve opposite and hypotenuse, all right? Two unknowns, we can't solve that. Not tangent, because it doesn't include hypotenuse at all. So we're left with cosine. As I fill in what I know, which is cosine 37 equals 17.5 over x, this looks a little bit different in that now x is not on the top. So isolating x is going to be a little bit different. To start, I'm going to multiply both sides by x so that it's no longer a denominator. So now I have this line. To isolate x now, I can divide by cosine 37. But Miss Morton, you say, when we divided by cosine earlier, it didn't work. The calculator wouldn't do it. Because we have an angle attached to it, cosine 37 has a value now. Cosine alone is a function, and we can't divide by that. But a value, we can. So x is 17.5 divided by cosine 37. Which gives us what? $21.9. There we go. Okay, we're almost done. Let's talk about finding angles. So now we know side lengths, but we need to find our unknown angle. It's the same approach. Start with SOHCAHTOA, identify which ratio will work, fill in your unknown, and solve. This dot here, this is the angle we're trying to find. So here we have opposite, adjacent, and hypotenuse. Ask yourself right now, which ratio would you use? We're missing an angle, which means that's S, C, or T. We have O and A. Yeah, that takes us to TOA. So tan theta equals opposite over adjacent. So that means that tan, we don't know angle R, is equal to 35 over 12. Okay. We can't divide by a function, so we'll use the inverse. So we have the inverse of tan times 35 over 12. If you're going to convert this to a decimal place, or decimal, remember that's fine, but you need 4 decimal places for accuracy. If you round down to any less, that can have the impact on several degrees of your final answer. And we round to our nearest degree, which gives us 71. Try B. We're looking for angle Z. We have opposite, hypotenuse, there's adjacent. I have opposite and hypotenuse, so I'm going to use sine. If you decide to do the ratio math first, it would look like this, 0.8824. To give us 62 degrees. Go ahead and wrap up C. That's what you should be getting, 76 degrees. Okay, we do our last question together. It's just a baby word problem. The foot of a ladder makes an angle of 30 degrees with the ground. It reaches 8 feet up a brick wall. How long is the ladder to one decimal place? Here's a big hint, draw a diagram. For any word problem, guys, draw a diagram. So here's a wall. Here's a floor. What angle do the wall and the floor meet at? Unless you live in a crazy house, 90 degrees. Is it important that I draw the 90-degree symbol? Yes, very. And so here's my ladder. I'm going to draw A, B, C for my labels. Now the foot of the ladder makes an angle of 30 degrees with the ground. It's tough to see, but that's a 30 right there. It reaches 8 feet up the wall, and I want to know how long the ladder itself is. So ask yourself, what part of SOHCAHTOA will give you the answer in this question? here's opposite, here's adjacent, here's hypotenuse. We want hypotenuse, tangent won't give us that. We have opposite, we don't have adjacent, so that rules out cosine, and we're left with so. So I'll just write out my solution now. Sine 30 equals 8 over x. See what you can do with rearranging this. I'm going to hide my work below. Remember, when x is a numerator or denominator, you're going to multiply both sides by x to have it be in a single line. From there, to isolate x, I'll divide both sides by 30. So I'm left with x equals 8 divided by sine 30, which, yes, as Grace just pointed out, is 16. Now remember, all of our measurements go to one decimal place. So even if that decimal place is 0, it shows precision. I need you to include that. So my last step would be, therefore, the length of the ladder is 16.0 feet. And that closes or rounds off our lesson on trigonometry today, so on SOHCAHTOA. You have a couple worksheets to work through. Okay. So SOHCAHTOA worksheet, you're going to find some angles and some values. I believe I have the answer key posted. There are some baby word problems for you to try on Thursday. We're going to look at some that are a little bit different. Namely, here I give you the diagram. On Thursday, I won't. And I also posted several GeoGebras. If you haven't done any GeoGebras before, click on the link. They're in the content section of our course, and it'll give you one problem. And you type in your answer, and it tells you if you're correct or not. And you can keep asking for more and more problems if you'd like to practice more. If you get to the point where you think, I get it, I'm crushing this, then move on and try another aspect, okay? Because they're each going to have you find solving something slightly different. I'm going to stick around for another 35 minutes if you guys would like to have any questions about math or about school stuff in general. Otherwise, have a lovely day. Please go enjoy the beautiful sunshine.